Hi, good morning. I will give you some indications about the partial exams, okay? Because I have received some questions about the form of the exam and how you can find the link for the exam and so on. And good morning. Okay, okay. Okay, so about the exams, registration, okay. Okay, a few words about the exam. Okay, as you know, and as I have already told during the previous lecture, you will have the possibility to consider partial exams, but it is not mandatory. If you want, you can consider partial exam, and the first partial exam for Module 1 of Resource Valuation and Decision-Making Methods is next week, will be next week, on the 4th of November at 10 o'clock in the morning. If you pass with a sufficient grade the first partial exam, you will have the possibility to consider in the second day, that is on the 13th of January, the possibility to have only the question for the second module partial exam. If you don't pass the first one, or if you decide to not consider the first partial exam, on the 13th of January, you will have the possibility to take the full exams. So for both the modules, Module 1 and Module 2. What are the rules for the exam? The rule is this, because I have to maintain the online possibility for the online students, I prefer to give you all the same modality. And so I prefer to consider an online exam for all the class, for all the students that would like to take the exam on the 4th of November. I have asked to the offices to have a room with PC. I prefer with PC of the university, because if you that are used to come in present for the lectures prefer to have the possibility to stay in the same class, in the same room, I prefer to. And so I can organize the same online exam, but with some students in presence and other students online. Okay? And so this is the rule. I have to have the confirmation about the room this morning or later tomorrow morning, because I have asked a room with PC, with personal computer. If I don't find a room with personal computer, I am not sure. I would ask also your opinion about this. I am not sure to consider a room like this and the possibility that you take the online exam with your own PC. Because I don't know what is the connection, what is the quality of the connection for all of you when you use the PC in the room. If the connection is good and I don't find a room with all the PC for you, we can also consider this, a room like this, and you have to come with your own PC. Okay? Is it okay for you? Okay. Okay, so the second best is this. The first best is a room with PC. The second best is a room like this, and you have to come with your own PC. Okay? Third thing, some students don't have actually the full enrollment because of the defense degree in the next week or some other similar things. They are few, but someone has asked me about this, and as last year, I will give the possibility to take the same exam to the students, but I need to have a list of the students that who don't have the full enrollment. Okay, I have asked to one of you, but I don't remember who is the student. Okay, and the online exam will be on the platform EOL, Esami Online, online exams, okay? And you will have the possibility to find the exam test in the morning of the exam. And I am used to put a password to the exam test. So after a general introduction about the exam test, only then you will have the possibility to open the exam test. And from that moment, the time will begin. Okay? Usually for 2 open questions, we are used to consider 1 hour. And so when you, or if you want to take the full exam, you have to consider 2 hours. Okay? Other questions?
Are there maybe some practice exams available?
Sorry?
Are there any practice questions available, or maybe exams from previous year that we can use to study?
One student is asking me about this, and I am going to put some other exam question, some other sample exam question on virtuale by Saturday, okay, tomorrow or Saturday morning. But if you check in the first file of slides, there is a sample exam test, only one, with 2 open questions for module 1 and 2 open questions for module 2. Okay, but I will give you some other sample questions for module 1, not for module 2. Okay?
Thank you. When you say open question, do you mean that we're allowed? When you say open question, is it like an open book exam? Are we allowed to have notes? Or
can you? Sorry.
So when you say it's an open question exam, is it like an open book exam where we can have notes with us or not?
Without notes, without books,
Yeah.
without nothing, without if we use smartphones and so on.
Yeah.
Okay, so without notes, but they are usually they have general questions about the main topics that we have considered in the first module. Okay, you don't have to do calculation or particular result. Okay, but you don't have to use notes. Okay, notes, notebooks, and so on. And the platform is Zoom. So inside exam online exam, there is the possibility to use Teams or Zoom. I am used to use Zoom with the sharing of your screen. Okay, so you have to share your screen, and so I can see that you are writing on the exam module. Okay, and the same I will do for the not fully enrolled students. Okay, they have to use Zoom. I am going to create a Zoom meeting, and they have to join Zoom. Okay, so same goes for all the students. Open classes and phone, and both fully enrolled and not fully enrolled. Okay, this morning I'm going to finish the first part, the part related to resource valuation methods. Okay, we have some more slides, not many. And after during the break or very close to the break, I will give you the link to fill the questionnaire about the satisfaction, your satisfaction on our course. And in the second part, I consider that I am able to begin the final topic of this module. The final topic deals with needs and uncertainty. because until now we have analyzed cost-benefit analysis and resource valuation without considering uncertainty for the future, but in the near term we have to consider uncertainty and risky situation for the future. So we have to deal with some sensitivity analysis or scenario analysis. If in the future something will happen with a certain probability, this is one scenario. If we consider another kind of probability, we can consider a second scenario. And third one, if you want to define another kind, another value for the probability of some of a particular field. And last thing, some students have inserted the name for the study field of the 2nd of December. Okay, and I will tell you something for this morning, for tomorrow morning, for all the class, for all the students, about the Rimini wastewater plant and the Rimini wastewater network, because the city of Rimini have done and is doing a lot of work about the sewage network, and the city has been cited recently in a UN report because it is a sort of best practice at international level for the kind of work that we are doing. The wastewater plant that we are going to visit on the 2nd of December is not a place with a lot of amenity because it is a wastewater plant. There are bad odors and so on. But it gives to you the idea of the network that a good city has to implement to manage wastewater. Okay?
You have a question?
Sorry?
You have a question?
Okay. Okay, for the question of Mariana Matos Fonseca, I'll give you other question to formulate your answer. I think that you have to study in the corresponding paragraph or chapter that deal with the argument of the question. Someone of you has asked me to send a sample of answers, but I am not going to send you a sample of answer because I suppose that the second cycle degree student has to know how to write a good answer, okay, to a specific question. Okay, Reza, yes, there are a lot of formulas in the book, not many, but yes, there are formulas, but you have to study formulas. It is not easy for all to write formulas in the exam test because it is a sort of wording system, but some of the formulas, for example, the net present value test formula, can be written also by using the keyboard without using a Microsoft equation editor and so on. So try to consider the possibility to describe the formula, the sum of the difference of the present value of the net benefit, and as present value you can explain what you mean for present value. There is the possibility to describe the most important formulas that we have learned. Okay? Okay, so another question. Okay, Mariana, I've understood your question, your point, because you are an Erasmus student and you are a bachelor. Okay, I can answer you with a specific email. I suppose that you have written me, if I remember well, by email. So we can communicate by email. Okay, so I'm going to share my screen. During last week, we have finished the last lecture while we were speaking about the value of statistical life. The value of statistical life refers to a monetary value for the human life. Okay, we are not used to speak about monetary value of human life apart from the situation in which we have to speak about compensation, for example, for road accident or for work-related accident. Okay, because in those cases we have to consider, for example, insurance compensation. Okay, generally, we can say that the value of statistical life can be estimated with three modalities: with the willingness to pay, with the cost of illness, and with the human capital. This was the last slide of Friday. What I mean with willingness to pay, we can ask people about their willingness to pay to avoid a debt risk or to avoid an injury risk. And we can ask people about their willingness to pay both by using stated preference methods, for example, the contingent valuation, with a specific question: what is your maximum willingness to pay to avoid this kind of risk? Or, in general, this is the form of the question. But we can use also the revealed preference methods, such as, for example, the hedonic pricing. If you remember, during the last lecture, the last Friday lecture, we spoke about the possibility to use hedonic pricing and hedonic wage analysis to understand what is the gap of accepted wages for workers that consider job position with particular risk of death or of injury. This is another possibility to analyze data that create the opportunity to define the value of statistical life by looking at the wage accepted by workers when they decide to accept or not a particular job position. In this case, we are analyzing revealed preferences because the workers are in a sort of indirect manner reflecting their attention to the life, to the injury risk, by accepting or not a job position for a particular wage. Okay, in the cost of illness, we have to consider several expenditures connected to the death or the injury, and we can analyze by summing up all the expenditure another kind of measure for the value of statistical life, and it is called cost of illness, value of statistical life, value of statistical life based on the cost of illness. The third one is the human capital. I told you something about this third modality, and the third modality is linked to the size of the lost productivity for a person that could die or that died at a particular age. Okay, so first of all, First point, willingness to pay. For the willingness to pay, one possibility, as I have told you a few minutes before, is to use stated preferences or revealed preferences. In the case of stated preferences, we can ask we can ask individuals about their willingness to pay to reduce mortality risk. Revealed preferences, marginal willingness to accept compensation. Economists can analyze the difference in pay between two jobs and determine how much of that difference stems from the difference in the risk of injury or death. If you remember, the other possibility that we have when we use the hedonic pricing method, the other frequent possibility is to analyze property prices. And in the case of property prices, we can analyze the gap in the average prices for flat with the sea view and similar flat without the sea view, or flat very close to a public garden and similar flat that are not close to the public garden. With the gap that we have in the average price of the two categories, we can analyze the value of the sea view and the value of the public park, of the public garden. And the same we can do if we analyze wages of workers. Okay? The doubt that we can have about the use of the willingness to pay to analyze the value of statistical life is linked to the fact that there is a strong heterogeneity when we consider stated preference-based value of statistical life and revealed preference-based value of statistical life. Look at this table. In this table, you can see that this is a sort of meta-analysis. That means that we have collected several papers with the analysis of value of statistical life, with revealed preference method, and several other papers that have analyzed the value of statistical life with stated preference approaches. And so meta-analysis report a sort of average value for both the kind of methods. You can see that if I consider stated preference, I have 1 million more with respect to the revealed preference one. Okay? So the average is more or less 2 million for each human life. The value of statistical life is more or less 2 million if I consider revealed preference methods. The average of the revealed preference methods empirical cases, empirical studies, while the average becomes 3 million more or less. So there is a strong heterogeneity, and if you look at the minimum and the maximum, you can see the size of this heterogeneity. Okay, here you can see other kind of figures for value of statistical life, that seriously injured, slightly injured, and in the value of statistical life you can consider also some additional cost of the accident for the society, and some, not only the additional cost of the accident for the society, but also additional willingness to pay of relatives and friends to avoid the death of a particular relative or a particular friend.
Which are the sectors of reference in this case? Because I can read classification.
Sorry?
Which are the sectors of reference in this case?
Sector?
Yeah, in this case.
Work.
Yeah, transportation and I can read transportation.
Yes, measure the marginal cost of transport, and so the critical cases analyzed there with road accident. Okay, road accident. is a big empirical literature when we analyze the value of statistical life linked to transportation accident, road accident, and so on. Another important theme with a lot of empirical cases deal with health, medical, the use of particular medical procedure or the use of particular medical drugs and so on. And another possibility, but I have some slides about this, is to analyze the value of statistical life linked to the environment. For example, natural hazard that can create deaths, that can create human life loss, such as, for example, storm, such as floods, such as earthquakes, and so on. So the three most important themes in which you can find empirical literature, empirical economical literature linked to the value of statistical life are transport, health, and environment. This is linked to the transport sector. Okay, a few words about the cost of illness method. It estimates the cost of a death with the sum of direct cost and indirect cost. Okay, what we can consider for direct cost, for example, expenditure, hospital costs, ambulance, drugs. Consider, for example, that in the US, the ambulance cost is a cost that has to be paid by the household, by the firm, by the individual, and not by the sanitary system, the health system, like, for example, in Italy or in other European countries. And so it is a sort of direct cost, because if you have an accident, a road accident or a work accident, the firm or the individual has to pay for the ambulance cost. When we consider the indirect cost, we can estimate the indirect cost with the human capital method. For example, the human capital method represents the third modality that I have explained, that I have anticipated to you, and it gives a value of health, life, with the individual lost productivity. Okay, in the human capital method, we are used to consider the individual lost productivity, but there are some critics about this approach, because with this approach we don't give a high value, for example, to elderly, to old age person, and we can consider a smaller value for women because we can analyze the individual lost productivity. So in this slide you can see the human capital method estimates a person's earning capacity by calculating the expected net earning lost due to a premature death. Okay, so some critics about the possibility to undervalue women, the elderly, and other minority groups. Okay, many countries have moved away from this kind of method, from the human capital approach, because of this limitation. But when we consider the insurance compensation for road accident, work accident, insurance compensation are partly linked to the human capital approach, partly linked. Okay? Now I have some very easy slide about some tables and charts contained in this OECD report of 2012, Mortality Risk Valuation in Environment, Health and Transport Policies, because we have to remember that the use of the value of statistical light can be very important to analyze the effectiveness or the ex-ante evaluation of a particular environmental policy or a particular health policy or a particular transport policy. Here you can see the frequency distribution of value of statistical light estimates by risk category, okay, and the value the values found, traffic, this color, health, this color, and environment, the dark blue. In the vertical axis, you have the number of estimates in each interval, and you can see that a lot of empirical work found an estimate of value of statistical life below 1 million, and other two important range of values are between 1 and 3 million and 3 and 6 million. And then you can have empirical studies with higher values for value of statistical life. And this explains again the strong heterogeneity that you have in the empirical application to analyze the value of statistical life. Here you can see the number of estimates and surveys according to risk category, environment, health, and traffic, and you can see more or less 700 works, 800, more than 800, and the number of surveys. Okay? Here you can see the mean, the median, and the standard error for the value of statistical life according to risk category. Environment has the higher range, health, the smaller one, and traffic, sort of medium range, between 0 and a value below 8 million. Okay? Can you follow? In the vertical axis, you have the values of the estimates of value of statistical life by typology, by kind of theme associated to the empirical work, environment, health, and traffic. Okay, so you can see a strong heterogeneity in the results by theme, okay, by theme, and also, as we can see in a few minutes, by kind of study. Here you have the number of value statistical life estimates and survey according to countries, Italy, France, United Kingdom, and other non-OECD countries. And frequency distribution of mean value statistical life estimates by country. It is not an important chart, but here you can see the number of surveys according to data collection method. Web-based, self-administered with personal computer, self-administered without personal computer, mail, telephone, face-to-face. Do you remember the survey modality? Okay, the survey modality that we have analyzed are more or less the same that empirical studies are used to apply. Okay, face-to-face, telephone, mail, web-based, and self-administered with personal computer or not. Okay, and here you can see the variability, the difference in range of the estimated values according to the modality of the collection of the survey, okay, mail. And if we consider the median is the lowest when we consider self-administered or face-to-face interview, while when we consider web-based, mail, and telephone, people are used to answer with an higher value. Okay, so there is a strong dependence of the empirical estimates on the kind of survey, on the modality of survey, and not only on the modality of survey, but also on the kind of question, as we will see in the next slide.
Sorry, can you move a little bit on the previous slide, please?
Sorry?
Can we
Previous
say that?
one?
Yes, because
Sorry, no, this is the next one. This is the previous one.
yes, I don't know if you see red the colors, but in years, face-to-face modality has increased a lot, even.
Face-to-face is the most frequent,
Yes.
face-to-face,
And
and then the self-administered with PC, okay, and then mail, and then this one is web-based. As you can see, the web-based survey are increasing in the last year
yes.
of the chart.
But somehow the technology modalities did not take place on the face-to-face modality. They are more or
It
less
depends.
50-50, little less.
Face-to-face can have the use of a laptop or of an iPad, for example, okay, to input, to insert data, okay, but it is not reported here. Face-to-face means that there is an interviewer with or without a digital tool.
So human contact is still considered very important.
Sorry?
Human contact is still considered very important.
In the face-to-face, there is the human contact, yes. The human contact, there is the human contact also by telephone, okay? If you look at this, okay, the human contact, you have human contact in the face-to-face, in the telephone, in the other kind of interviewing system. At this, here you can see the value of statistical life estimates by kind of question. Do you remember the kind of question that we have analyzed in the contingent valuation? Contingent valuation, open-ended question. And you have the higher variability in the result because you can receive very high answer because people understand that they have not to pay for true, okay, because of the saying bias and because of other factors linked to the fact that when you ask with an open-ended question, people can state whatever they have in mind. CIVU contingent valuation cards means the use of a table with some values included in a range, and people have to answer by selecting the preferred value. But it is not an open-ended question because you are giving to people in your questionnaire a table with a set of values with a minimum that is 0 and the maximum that is defined. Okay? Contingent valuation, dichotomous choice, conjoint analysis. Okay, conjoint analysis means choice experiment, so the value of statistical life estimated in a study of choice experiment, and so you know that in a choice experiment or conjoint analysis, there is a particular question that asks people about their willingness to pay for some attributes and level associated to the attributes. Okay? Other kind of elicitation method. So in this table you have value of statistical estimates by elicitation method. Okay. A major point, a major issue in all the value of statistical life survey is whether or not the respondents understand the magnitude of the risk change they are being asked to value. If you remember, last Friday, I told you that we have to ask about the willingness to pay for a minimum change in the risk of debt. 1 in 10,000 to 1 in 15,000, for example. But it could be not very easy to understand the kind of marginal change. And so, to be sure that people understand the magnitude of the risk change, some check question like this can be used in questionnaire that ask people about their willingness to pay or their willingness to accept for a change in the risk of debt. Here, there is an example of a risk communication tool. Person one, suppose there are two people. Person one, chance of death 5 in 1,000 over the next 10 years. Person 2, chance of death 10 in 1,000 over the next 10 years. Which person is the most likely to die in the next 10 years? And press the blue key to continue. So, in the questionnaire with the topic that have been defined, that can be defined to analyze the value of statistical life, some example of risk communication tool like this can be inserted to be sure that people understand what is the change in the risk of that associated to the most important question. Okay? Okay, now, if you remember this chart, we are considering a lot of methods, okay, that can be used for change in environmental quality or measurable change in production. If we look at the health effects for the debt, we have cost effectiveness analysis of prevention, human capital, and now we know what we mean for human capital, or hedonic wage approach, and now we know what we mean with hedonic wage approach, or contingent valuation. So, for each kind of change in environmental quality that is linked to the environment or to the health, we can have different methods that can be used. And so we are analyzing in this module all the methods that can be used. And according to the theme, according to the context, according to the country, a researcher can use one method or another method. Okay, so we have to consider another method that is called preventive expenditure, or in some cases defensive expenditure, that can be used for air and water quality. For air and water quality, change in environmental quality, you can see cost effectiveness of prevention, and we know what we mean for cost effectiveness. Contingent valuation, and the contingent valuation is the most used one, but we miss to know what we mean with preventive expenditure and with replication cost. Now we will give a look to the preventive expenditure. Preventive expenditure or defensive expenditure method is a method that puts the attention on the analysis of about the expenditures in response to something undesirable, for example, pollution. If smog pollution imposed worsens, you may spend more on having your windows cleaned or for an air conditioner, for example, because you have to stay with the closed window and you want to consider a fresh air in your home, and so you can consider the buying of an air conditioner. The change in expenditure can be used as a measure of the change in pollution. Some other examples. In developing countries, people are used to boil water for cooking and drinking, or also for drink, or only for drinking, because tap water, is not safe for human life in some specific contexts in some developing countries. For example, one of the most polluted area, according to the water system in the world, is the Mekong Delta. Do you know the Mekong Delta? Mekong, the Mekong Delta is in Bangladesh, close to Laos, close to Cambodia. Okay, the Mekong Delta is one of the most polluted river area of the world. But a lot of people live close to the Mekong Delta or in the Mekong Delta, and they are exposed to unsafe water because they don't have a cleaning system for water, and so they are used to use water linked to the river. Okay? So, another kind of defensive expenditure, here you can see different names for this method: averting behavior, defensive expenditure, avoidance expenditure, preventive expenditure. They are synonymous. So, if you have to boil water for cooking and drinking, you have to pay a direct and an indirect cost to have safe water. Or when we travel in a developing country, we are used to buy bottled water, also to wash our teeth in some cases, because tap water is unsafe. And so this means that you are paying something, that you are considering expenditure to reduce the risk of illness. Stay indoors during times of heavy air pollution, or purchasing an air conditioner, or for example buying an helmet to travel by bike, while it is not mandatory, for example, in Italy. Okay? Okay, so this kind of approach takes the cues from what people are observed to spend to protect themselves against a potential or an actual decline in their environmental quality. So, if we observe people why they are spending, it means that we are analyzing revealed preference of people. So someone can consider this kind of method inside the revealed preference approach. In some books, you can find a taxonomy with a difference between revealed preference methods and defensive expenditure, but on a conceptual basis, we can consider that if we are observing people while they are spending to abate a certain risk for unsafe water, for pollution, and so on, we are observing revealed preference of people by looking at their market expenditure for something, for bottled waters, for air conditioner, for double windows, and so on. People buy goods and services which help them to preserve the environment. This definition source is done by European Commission in 2000, analysis of the fundamental concept of resource management. Now we know what we mean with preventive expenditure, but we miss the concept about replacement and relocation cost. It is quite easy, okay? If we have an environmental damage, we have to consider, for example, how to restore the environmental good. Think about a beach with after an oil spill close to the coast, and you can consider some people to clean the beach, to help seabird, to help sea mammals, okay? But you have to pay for this restorement of the environmental good. So we can consider also replacement cost, the replacement cost approach. It must be possible to identify a substitute for the ecosystem services. So to restore an environmental good, we can consider restoring expenditures or a substitute good. A substitute good can be thought, for example, for a forest burning. If we lose a forest because of a burning, okay, and we cannot consider again new trees in the same area, at least for the first 2 years, okay, then we can consider a sort of substitute in another similar area where we can consider the planting of new trees. So we can reconstruct, rebuild the damaged environmental good with a substitute. Does the substitute have the substitute good, the same utility of the lost good? In many cases, no. Because in many cases, if we have lost a good, an environmental good, and we can consider a substitute area to recreate the environmental good, at the beginning, for many years, we don't have the same utility, we don't have the same environmental services that we had before with the burned forest, for example. Here you can see an example of restoring expenditure, because when you have a burn, you have to consider, for example, Canadair with pilot, with the use of airplane, and so the society has to pay for this kind of restoring expenditure. Okay? After a forest burning, we can consider the same area for the first year for new planting, for new trees, but an open question can be now this: what are the benefits of the restored environmental good after environmental damage? And what are the benefits of a possible substitute good? What do you think about this? What are the benefits of the restored environmental good? And what are the benefits of a possible substitute good? If you have a burned area and you can consider a similar in size area for new trees, okay, you will have an utility associated to the new area, but the utility will be smaller with respect to the previous utility, okay? Because in the burned area, you have lost big sized trees, old age trees, while in the substitute area, you are considering new and young trees. So at the beginning, you cannot have the same utility, the same benefits associated to the lost area. Okay? Look at this slide. Here you have the quality of the environmental good, okay, and the restoration benefits and the restoration cost. you can have this situation. You have to pay increasing restoration cost, but the restoration benefits can be at a certain point smaller with respect to the marginal cost that you have to pay. So when you consider restoring expenditure, you can spend until a certain level, but not until the 100% level in quality that you had before. Okay? Look at this. Here you can see the benefit associated to the damaged good, B, for example, and the benefit associated to the substitute good. The benefit associated to the substitute good are below in size with respect to the benefit associated to the damaged good. If you have lost a forest, the benefits of the previous existing forest are represented by this curve. If you have defined a new area with new trees with the same size of the previous existing forest, okay, you will have benefits, okay, but the associated benefits will be smaller with respect to the associated benefit to the lost forest. Okay? And what about the cost of the substitute good? The cost of the substitute good can be increasing in the shape, and after a certain point, they can become very high and higher with respect to the marginal increment that you have for the benefits. So this is the reason why the cost of the substitute good can reach a certain level, but not the level to obtain the 100% of restoration. Okay? So, benefits of the substitute good exist, they are positive, but they are below with respect to the benefit associated to the previous existing environmental good. And the same for environmental services. So, when we consider the possibility to use replacement, relocation cost, we have to keep in our mind that the substitute good is positive, okay, has positive values, it has positive benefit, but it cannot substitute the previous existing good, okay, at the 100%, I mean. Okay, now, the last part is this. In this useful chart, you don't only have methods for the change in environmental quality, but that are inside the environmental impact, but you have also measurable change in production. For example, a polluted soil or a polluted air could decrease the production of some agricultural crops. Okay? If you have a measurable change in production, yes, for example, then you can observe market prices. If you can imagine that you have a loss in a particular agricultural crop, in the production of a particular agricultural crop of 10%, then you can measure the value of this kind of damage by looking at the market price of this agricultural product. Okay, so it is quite easy to consider this on the conceptual basis. The name of this kind of method or this kind of approach is used change in productivity approach, or if you don't have market prices, then you can use surrogate market approach to apply shadow prices to change in production. You can find some not real existing prices, but similar in your consideration prices to analyze the loss that you have measured in the production of a particular agricultural crop or a similar in context. Here we have to speak about production function methods. For example, many non-marketed environmental goods are used in production. For example, the inputs, the natural inputs, the environmental inputs, water, soil, okay? And they are indirectly used in the sense that ecological function of the resource were supporting or protecting economic activity. You can consider a sort of two-step procedure to analyze the loss that you have because of an environmental impact. The two-step procedure is this. You have to determine the physical effects of a change. For example, how much the cleaner water increases the catch by John in the river. And then you have to value the impact of this change in terms of the corresponding change in the market output. How much more gains John with the cleaner water due to the increase in catch? And so, if a fisherman has the possibility to catch more fish because the water are cleaner with respect to the past, okay, then we can have the possibility to estimate the gain for the fisherman because of the increased catch. But the same we can do when we have loss in agricultural product, in the possibility to catch fish, and so on. When we have an oil spill, for several times we cannot fish with boats in the area affected by the oil spill. And so we can measure the change in production for the fishermen that are used to fish in that area. Okay, because they have to go they have to go to fish in another area and to cover more distance and to pay more for the engine, for the boat, for the fuel, and so on. But even because they have to consider the loss in the possibility to catch fish in the same area affected by the oil spill. So, in the production function methods, the non-marketed good is treated as an input into the economic activity, okay? And like any other input, its value can be equated with its impact on the productivity of any marketed output. Look at this. If I have, for example, the production function constraint that is represented by this, Q is the output, and Z is the quantity of inputs, and E is the environmental quality, okay? If I have the production function constraint like this, I can consider the change in the environmental quality and the effect of the change in the environmental quality in the production, in the output, okay? And then if I consider the cost function related to the wage, to the quantity of, to the quantity of output and to the environmental quality, then I can consider this. And it is very easy to understand this kind of chart because here you have the marginal willingness to pay for crops and on the horizontal axis you have agricultural crops, okay? And here you have the marginal cost with good air quality and marginal cost with bad air quality. If your marginal cost with bad air quality are higher with respect to the marginal cost with good air quality, you are paying for the bad air quality in terms of reduction of the quantity of your output. Okay, if your output for this particular agricultural crops is Q1, if you have good air quality condition, with bad air quality condition, you will have a reduction in your agricultural crops. So you can measure the size of this loss, but in many situations you will have to pay more to face for the bad air quality condition. And so your marginal cost increase because of the bad air quality and your output will decrease. You can measure the decreasing in the output by looking at the market price of this kind of output. Okay? So the logic is quite easy. The logic is that you have to look at the physical effects of the environmental impact on your output. Your output can be related to an agricultural crops, to fishing productivity, to fishing catching, and so on, but you can measure the size of the loss by looking at the market price.
Can we use this method to assess the impact of climate change on crops?
Yes. Also, the impacts of climate change on crops can be evaluated, and there are empirical studies that have done this because of low in quantity water season, because of drought, and because of floods, for example. Also, floods can destroy agricultural crops. Okay. And so there are empirical papers that have evaluated the marginal effects of climate change on agriculture, on the possibility to fish in rivers and sea and so on. It depends on the context and on the country that you want to analyze, because if you want to use, for example, the benefit transfer method, if you remember, with the benefit transfer, we can analyze empirical studies that deal with our interest, our theme, and then transfer the value estimated by the empirical studies in our context. But the contexts have to be similar, both the context of my analysis and the context of the empirical paper that I want to consider to transfer values, estimates, total economic values, biodiversity values, and so on.
If you remember, we talked about the recurrent function linked to the unit price method. So what's the difference if we use the production function method or the recurrent one? Because the recurrent one maybe is more useful for just for the agriculture. So this is to me like a more general approach that we can employ in various kind of sectors.
We can use, for example, production function methods linked to the effects of climate change also for the production of honey. Honey. Do you know honey can be affected by climate change because bees can be more productive or not because of climate change, and there are also studies that use production function methods linked to both things, climate change effects on the production of honey, and how we can face this problem and how we can help bees to maintain their production of honey. Okay? For example, in urban cities, we can maintain set-aside area. Set-aside area means area without maintenance activity for the green, for the planting, and so on, for the plant. Okay, and so if we maintain some set-aside area in urban cities, even if they are small set-aside area, we can help biodiversity in the presence of insects and also of bees. Okay, but the most part of the production of honey, of course, is related to the use and the quality of peri-urban areas or non-urban areas, I know. And so in this kind of areas, we can consider the climate change effect. But even in the case of urban areas, we can do something to help the production and the activity of bees. Okay. Brief summary: main economic valuation methods for natural resource. So, value benefit with real market prices for goods and services. For example, production function approach means also dose response. If pollution decreases agricultural production, the production loss can be evaluated at market price. Dose response is another kind of method is another kind of name for the same production function approach. Dose response. We can measure the effect of a particular change in production in the response of the production quantity, of the production output. Valuing benefits with real market prices for environmental protection inputs. And this corresponds to defensive expenditure, and there are a set of synonyms: averting behavior, defensive expenditure, avoidance expenditure, preventive expenditure. If you have to boil water, to have safe water, if you have to buy bottled water for drinking, if you have to purchase an air conditioner, we can observe this kind of expenditure, and this kind of expenditure can be analyzed in the context of defensive expenditure to reduce a particular risk or to reduce the effect of pollution. And finally, we can value benefits impacts through surveys by the use of stated preference methods like contingent valuation, the most used one, choice modeling, conjoint analysis, choice experiment. They are in the same family of methods. Okay, sometimes you can use choice experiment, some other times conjoint analysis, but it is the same. We mean that we are using survey with a questionnaire in which we don't have only the question about the willingness to pay, but we have the choice set with 3 different alternatives, and we have to select one of the alternatives described with several attributes, a few attributes, and different levels for each one of the attributes. Then, final one, valuing benefits impacts from observed behavior. So, through the analysis of revealed preference, that means that we can consider revealed preference methods. And the 2 most important methods inside the revealed preference methods, inside the revealed preference approach, are hedonics pricing and travel cost method. Okay? In general, we have to conclude that stated preference methodologies are now actually seen to enjoy advantage over revealed preference methods in developing countries. In developing countries, it is more easy to consider stated preference methods, okay, while in developed countries, revealed preference approach can be considered. For example, for hedonic pricing in properties, or for hedonic wage analysis for work behavior, workers' behavior. Okay, so with these two slides, we have a sort of summary of the main methods that we can consider to analyze benefits and costs associated with environmental goods and services. The most formalized methods deal with the stated preference methods and the prevailed preference methods, contingent valuation choice experiment for stated preference, and the hedonic pricing and travel cost for prevailed preference. There are other methods that are easier to be applied, okay, but they require the possibility to measure the size of the pollution and the effect of the pollution of on a particular output. Or they require that you are able to estimate the preventive expenditure with respect to a particular effect of pollution or of the presence of unsafe water and so on. Okay, so these two slides correspond more or less to all we have seen according to this chart, to this figure. Okay, so I think that we can consider a 20-minute break, and then before the end of the break, I will put here the link for the questionnaire for to collect your opinion about the course, and then we will continue with the last topic of this first module. Okay? So, 20 minutes break, it means that we can begin. Certo.
Io devo dire, credo che già tutte ragazze
Sì, si può passare la mascherina per
perché devo dire che pure un'altra ragazza mi dire la stessa cosa, che noi stiamo sulla lezioni da pendolari.
Sì.
E abbiamo visto che
Ecco, mi sono dimenticata che c'è un'informazione anche per quella cosa lì.
Esatto.
E gliela dico già così. Hi, here we are. We can open the possibility to a minute because I call your colleague. Quindi sì. 28 online, 28. Ok. No, sbagliato. Okay. I think that you can open the questionnaire with this QR code. Okay, this QR code. If you have a problem with the QR code, I can put here the other address. If you have problem with the QR code, you can use val.unibo.it. have put the link on the chat, okay?
Sorry, Professor, can you share the QR again? Sorry.
I have
But if there is a code, because I accessed the link.
I try, but I cannot see the QR code now because I cannot close, and if I.
Okay. Okay. I think someone is going to share.
Okay.
Sorry.
Is it okay?
Yeah, I think yes, I understand.
Try to go to this web address, otherwise.
It's working, yes. Thank you.
I wait some other minutes because I can see that only 11 questionnaires have been filled. Please fill the questionnaire. If someone of you have the possibility to put the picture of the QR code on the chat, please put the QR code because I cannot reopen the QR code. I if because the question, because it is open and I cannot see. '24. Here. Here you can see the QR code. Have you all finished in the room or not? Yeah? Okay. Okay, I can leave the system open, so if someone would like to answer to the questionnaire, okay, 30, 45, okay. And you can find the questionnaire at this link or with this image. Okay, I can go on. Okay, at the beginning of this lecture, I told you something about the format of the exam, of the partial exam. Okay, so you can share the information with your colleagues that were not here at the beginning. But I have forgotten to tell you something about the timetable of the second cycle, because someone asked me about the possibility to change the timetable when Professor Papadeas will begin the classes, his classes, because actually you can see in the timetable 4 days, Monday and Tuesday with Papadeas, and Thursday and Friday with Professor Dieci. I'm referring to the second module of this course, okay? But we are changing the timetable to give the possibility to the commuting people to come to Rimini only 3 days and not 4. We have not found a possibility to have all the hours in the same 2 days as now, because now you have all classes on Thursday and Friday, but probably the timetable will consider when Professor Papadeas will begin, Tuesday, Thursday and Friday. So 3 commuting days. After the 29th of November, Professor Papadeas will come back to Greece, to his home country. So only the 2 final weeks regarding the classes of Papadeas will be online only. So we ask you to have the patience to consider for 3 weeks, 3 commuting days, okay, for people who are commuting, 3 commuting days, because you will have Professor Dieci on Thursday and Friday, as now, and Professor Papadeas on, I consider, Tuesday and Thursday, or Monday and Thursday, but I prefer Tuesday and Thursday. Okay? So we are arranging this change in the timetable. If you have other requests, please ask us, to me, to Ilaria Tamburini, or to Lucrezia Leonardoni, who is your tutor. Okay. Now we can go on. We have finished with the 2 summary slides about the valuation methods, both the methods with real market prices, both the categories with real market prices, and to surveys or observed behavior give you the possibility to estimate environmental benefits or environmental costs. Now we have to consider the last topic of our module, and the last topic deals with reversibility, risk and uncertainty, and to study the corresponding part to this final set of slides, you have to study chapter 13 of the permanent book, not all the paragraphs, because some paragraphs can be avoided, and you have all the list of the material that you have to study in one of the first files that I have put on Virtuale. So on Virtuale you have all the material until now, and you miss the slide of this morning and the slide of tomorrow, and I will upload after the lecture as usual. Okay, so what are the learning objectives that we have to consider when we speak about reversibility, risk and uncertainty? We have to find out how risk affects environmental decision making and have the concepts of option value and option price explained. At this stage, we know what we mean with option value, and we know also what we mean with quasi-option value, okay? But we have to learn more because these concepts are related to risk and uncertainty for the future. And we have to see how reversibility affects environmental decision making and learn about quasi-option value. So, examples and definition of risk. If I have to consider, for example, environmental risk, I have to consider this, the likelihood or the probability of injury, disease, or death resulting from exposure to a potential environmental hazard. If I consider pollution risk, so a specific environmental risk, then I have to consider the probability of harm to human health, property or the environment posed by the introduction of an not desirable substances into the ecosystem. When I consider the reversibility concept linked to an environmental damage refers to a permanent loss of environmental assets or environmental quality requiring preventive action rather than restoration or cleanup. Because with the reversibility, we have to refer to the fact that we can have in the future something that we cannot change to restore to the previous condition. Okay? To deal with the concept of risk and the reversibility, and also to deal about the concept of uncertainty, we have to introduce the concept of probability. I know that the most of you or all of you know the concept of probability, but we have to recall something. Probability is a measure of likelihood an outcome will occur. For example, if an outcome cannot happen, the probability will be 0. If an outcome is certain to occur, probability will be equal to 1. So, if I consider the fact that the not occurring outcome corresponds to a probability equal to 0, and the always occurred outcome corresponds to probability equal to 1, I am quite sure that the range of other kind of outcomes lie between 0 and 1. So 0 and 1 is the range that I have to consider for the probability of a particular outcome. So the basic ideas of probability. Imagine that we have a person that tosses a coin 5 times. Okay? When I toss the coin, I can have head or tail, testa o croce. Each time it comes down heads. What is the probability that it will come down heads on the 6th toss? What do you think about this? I have a coin, it is a fair coin, and I have 2 possible outcomes, head or tail. If I toss the coin for 5 times and always I have obtained head, what is the probability of having head at the 6th toss of the coin? What do you consider?
1/2.
Sorry?
1/2.
1/2, 1/2, because you have two possible outcomes and have corresponds to one of the possible outcomes. So you can avoid to consider previous tosses of the coin, and you can consider only the two possibilities that the coin gives. Okay? So if I consider this way of calculating the probability, 50%, half, 1/2, okay, I am considering sort of a priori probability concept. A priori means that before the tossing of the coin, I can calculate the probability of having head. A minute, because I check for the questionnaire. Okay, 41. I have 4 missing questionnaire. If you can finish, I will close a little bit later. Okay. Okay. Some term, glossary term. A trial is an action which results in one of several possible outcomes. An experiment consists of a number of trials. An event is a set of outcomes which have something in common. We have to distinguish between objective probability and subjective probability. What we mean with objective probability and what we mean with subjective probability. When probability are assigned on the basis of knowledge, they are something referred to as objective probabilities. Okay? And so, if I consider that with a coin, the probability of having head is equal to 50%, 1/2, okay? This is based on a previous knowledge about the coin. And so this is an objective probability. The most common definition for an objective probability is the so-called a priori definition of probability for equally likely outcome. So I have to be sure that each one of the outcomes has the same probability of appear. The ratio to the favorable cases are to the whole number of cases possible, and we don't have to carry out an experiment, so we don't have to toss the coin. As we know, if we toss the coin 10 times, we can have 5 heads and 5 tails, or 7 heads and 3 tails, or even 10 heads and 0 tails. But if the coin is fair, we are sure that the a priori probability of having head and of having tail is equal to the 50%. If I want to toss the coin 1,000 times, okay, I can check for the results, but the probability that I can calculate it on the basis of the empirical tosses, of the empirical cases, can be called frequency-based probability calculation. Okay? The frequency definition of probability is based on experimental data, as I have told you a few minutes ago. If in a large number of trials, small n, R of these trials result in event E, the probability of event E is R out of n. So the number of trials, I have to put below the line the number of trials, and I have to put the number of positive or favorable outcomes above the line. Frequency which certain outcomes will occur, objective probability of an outcome can be measured from past experiences, but the range of possible values for a probability is 0 to 1. If the probability is equal to 0, it means that you don't have the possibility that an outcome will occur. If the probability is equal to 1, you are certain about the outcome. The outcome is certain. A minute. Okay, I will close. Okay. Okay. This is done. Okay. Subjective probability. Some economists or researchers treat the decision-making problem as being dealt with by the assignment of subjective probability. What I mean with subjective probability? I mean that a future possible outcome, a future possible event, can be evaluated with a particular probability defined on a subjective basis, with experts, with a pool of independent individuals. Okay, I can define also some subjective probability values. The decision maker proceeds by assigning, on the basis of judgment, to each of the possible outcomes a set of weights that satisfy the requirement for probabilities, positive numbers, and that have to sum to unity, because we have clear in mind that the probability values could lie between 0 and 1. So the definition for subjective probability is this: numeric measure of change of chance probability that reflects the degree of a personal belief in the likelihood of an occurrence. Both subjective and objective probabilities are mutually exclusive. Only one outcome will occur. Okay? For example, a household will either go to the movies this weekend or not. Yes or no? Probability associated with each possible outcome always add up to 1. This is a strict requirement for the probability. If 1 out of 4 is probability household goes to the movie, then 3 out of 4 is probability that the household will not go to the movie. These possible outcomes exhaust all possible outcomes, and probability sum to 1. In general, if we assume a finite number of outcomes, k, then we can add all the probability for each one of the outcomes, and the result has to be 1. Okay? So far, many of our analysis so far has assumed that the consequences of decisions are known with certainty and are reversible. But resource decisions concern the future as well as the present, and we cannot know the future with certainty. So we have to consider uncertainty for the future and probability values for some outcomes and for other outcomes. This is the reason why, at the end of this first module, we are considering uncertainty, future, risk, and some irreversibility linked with future outcome. Now, many decisions have consequences that are irreversible, because we can have also an incomplete knowledge about the consequences, okay? And so risk and uncertainty are two possible kinds of imperfect knowledge. It's important to see what difference it makes to the analysis if we assume that future is certain or is not known with certainty, and we can consider, for example, for the future, some forecasting scenarios. Okay, forecasting scenario average with the possibility to occur of a particular outcome, for forecasting scenario high with a high probability to occur for a particular outcome, forecasting scenario low with a low probability to occur for a particular outcome. So now we can define the difference between risk and uncertainty. If we consider risk, all possible consequences of a decision can be enumerated and probability assigned to each possibility. State of the world, state of nature, state, okay, or high for the forecasting scenario, average for the forecasting scenario, low for the forecasting scenario. The difference between risk and uncertainty deals with this. Uncertainty, we can speak about uncertainty where all possible consequences of a decision can be enumerated, but probabilities cannot be assigned. So with risk, we have the possibility to assign all the probabilities to all the possible consequences. With uncertainty, we can enumerate the consequences, but we cannot assign to each one of the consequences the probability level. Okay? Radical uncertainty means that we have not the possibility to define all the consequences and we cannot assign to them a probability level. Okay. What can we consider to deal with risk? The classic risk situation are gambling and insurance. Gambling means gioco d'azzardo. Insurance, assicurazioni. Okay, so the two most used classic risk situations are gambling and insurance. Not always the distinction that we have seen about risk and uncertainty can be considered by economists, because when we have lack of objective probabilities, sometimes economists will proceed with the assignment of subjective probabilities. In many environmental contexts, for example, probabilities are assigned on the basis of modeling, for example, urban air pollution, nuclear accidents, and so on. Here you have, for instance, the process of building maps showing concentration of air quality indicators, okay, and the exceedance of indicator concentration and exposure estimates. So we can define a model and we can estimate the population density, the population characteristic, and we can estimate the amount of population at a certain risk. And we can estimate also the kind of ecosystems at risk. Okay? Here, for example, you have a map presented in some report of the European Environmental Agency, and here you have the map showing the probability of exceeding the limit value of PM10, okay, at the European scale. It is a map different with respect to other similar maps that we saw in previous lectures, because in previous lectures we saw map with reported values. Here you can see forecasted value. Okay, so there are some models that give to you the possibility to provide a forecast of values with a certain probability level. This is the annual average of PM10, and this is the PM10 indicator at the 36th maximum daily mean. Okay. Climate change is another problem, is another kind of problem that can be connected with radical uncertainty, because we cannot be able to enumerate and to identify all the possible consequences of climate change for the future. We can imagine some of the consequences, but we can have the probability that we are not considering all the possible climate change effects. So the climate change problem exemplifies sort of topic issue linked to radical uncertainty. Okay? If we look at the global average in temperature, we know that there is an increasing path with a steeper trend in the last decades, and we know that the associated effects are very heavy. Okay, we know that the increasing path is linked, is associated to the increasing value for global CO2 emissions, and we know that there are some forecast scenarios prepared by the IPCC, and that we can reach some future value for the global warming depending on the way that we organize countries to face this problem and to reduce greenhouse gas emissions. Okay. Again, basic concepts for risk analysis. The difference between expected value, expected utility, risk neutrality, aversion, risk aversion, risk preference, certainty equivalence, and cost of risk bearing. What is the expected value or payoff? Look at this. If I have probabilities to calculate expected values for uncertain outcomes or for uncertain outcome, I can imagine that I can have n possible values, x1, x2, xn. Moreover, we know the probability of obtaining each one of the values. If I have the probability of each one of the outcomes, I can calculate the probability of the outcome 1 times the outcome 1 if the outcome 1 is linked to, for example, a monetary value, plus the probability of having outcome 2 times the value associated to outcome 2, and the same for the outcome n. Look at this numerical example. If I have a die with 6 faces, dado, okay, and you are made the following proposal. You pay $3 for the right to roll a die once. You then roll the die and are paid the number of dollars shown on the die. So, if after you have rolled the die, you have found 5, you will receive $5. If the outcome is 1, you will receive $1. If the outcome is 3, you will receive $3. Okay. Should you accept the proposal? Think about this example. You have to pay $3 to have the right to roll the die once, only one time. And you will receive the amount of dollar equal to the number that you will have on the die. Should you accept the proposal? What is the calculation that you have to consider? you have to calculate the expected payoff. You have the probability equal to 1 out of 6 of receiving $1, plus the probability equal to 1 out of 6 of receiving $2, plus, again, the probability equal to 1 out of 6 of receiving $3, and so on. If you make this calculation, you will receive an expected payoff equal to 3.5. The expected payoff is higher with respect to the amount of money that you have to pay to have the right to roll the die. Would you like to accept a game like this or no? Or no? What is your opinion?
Depends on on our risk propension. If we are risk lovers or neutral, or
It depends on?
our risk propension.
Okay. Okay. It depends on your risk propension, your risk-seeking habits or not. Okay? Because you have to pay 3 for sure to have the possibility of receive 3 or more. The expected payoff is 3.5, so if you compare the expected payoff with the amount of money that you have to pay for sure, it seems a positive gain for you, but you know that the expected payoff is not sure. Why? You have to pay $3 for 2. Okay? So, the expected payoff from the die throw is greater than the price, so $3 is the price, so a risk-neutral player accepts the proposal, but a risk-averse player could not accept the proposal. A risk-seeking player could accept the proposal. Look at this other example. Consider this example. A risk-neutral person is indifferent between $25 for certain or a 25% chance of earning $100 and a 75% chance of earning 0. Look at this. In this example, you can imagine that in this sentence you have a game with the 25% of probability of giving you the possibility to earn $100, but the 75% of probability of giving you 0. So, if you calculate the expected payoff is equal to 25. 25 is the same amount that you have to pay for certain to have the possibility to participate to this gamble, and the expected payoff is equal to 25. So a risk-neutral person could accept, but a risk-averse person will not accept a game like this, because a risk-averse person consider the 75% chance of earning 0 with an high value. 3 out of 4 is the possibility that you have, while 1 out of 4 is the possibility that you will receive $100. Okay? Again, a risk-neutral person agrees to pay $3 to roll a die once and receives as payment the number of dollars shown on the die, the example of before. The expected payoff is equal to 3.5 and you have to pay 3. Okay, but many people are risk averse. And so it means that a lot of people prefer $25 for certainty, with certainty, to the uncertain gamble with an expected payoff equal to 25. okay? Or might be unwilling to pay $3 for the right to roll the die once, so imagine that people base their decision on expected payoffs alone may yield misleading results. So, if we compare the expected payoff with the amount of money that we have to pay for certainty, we have to consider that risk-averse individual will not pay an amount of money equal to the expected payoff or just a little below the expected payoff, because a risk-averse individual will consider also the probability of the unfavorable outcomes. So, what can we do to account for the fact that many people are risk-averse? Because if we think about our behavior in similar contexts, we are not prone to accept gain like the proposed one. Okay? So we can use the concept of expected utility. Expected utility is a concept different with respect to the expected payoff. Look at this, and then we will stop in a few minutes and we will continue tomorrow. If we have a payoff expressed in dollars, then we can imagine that there will be an utility level associated to the expected payoff, okay? And we can imagine that the utility function is an increasing function that corresponds to an increasing value for x. The function ux gives an individual's level of satisfaction in fictional utils from receiving payoff amount x and is known as an utility function. If we consider the certain payoff of equal $25, we can state that the certain payoff is preferred to the gamble due to risk aversion. Then we want a utility function that satisfies this. The utility associated to the certain payoff equal to $25 has to be bigger than the utility associated with the expected payoff, because the expected payoff is 25, but 25 is not certain. So the utility associated with the expected payoff has to be smaller with respect to the utility associated to the same amount of money for true. The question can be for you, do you prefer $25 with certainty or $25 as the result of a gamble and so as the result of the expected payoff calculation? In general, people are risk averse, so they prefer $25 with certainty. And this is more or less true for all of us. That means that the utility associated to $25 with certainty is bigger than the utility associated to $25 as the result of the gamble. Because $25 as the result of the gamble are not certain. Do you remember this? 3.5 is the result of the expected payoff, but the utility associated with the result of the expected payoff is smaller than the utility associated to $3.5 with certainty. We prefer $3.5 with certainty instead of $3.5 with uncertainty, because this is the result of the expected payoff. And same if I consider this example, $25 for certain, or 25% probability of earning $100 and 75% probability of earning zero. The expected payoff of this example is 25, but 25 are not sure for you, are not sure for us, because we have 3 out of 4 chance to have zero and not 25. 25 is a sort of uncertain result. Okay, so if the certain payoff of 25 is preferred to the gamble, for the utility function that we are searching for, we have to require this, that the utility associated to the 25 for true with certainty has to be bigger than the utility associated to the 25 as the result of the gamble. Okay? So here you can see some formulas for risk analysis. The expected monetary value is linked to the calculation done with probability levels times the value plus the other probability level times the other value. If you have only 2 possible outcomes, you will have the probability P1 for the first outcome and the probability P2 for the second outcome. Okay? The expected utility of the gamble is different with respect to the expected payoff, because the expected payoff is only numerical, while the expected utility consists in a judgment about the utility associated to the values. So the expected utility is linked to the probability level of the first outcome and the utility level associated with the first outcome, plus the remaining probability level, if you have only 2 outcomes, times the utility associated to the second outcome. Then we will deal tomorrow morning with the certainty equivalent of the gamble. The certainty equivalent of the gamble is the value for x corresponding to its expected utility. So I mean that if I had a certain an utility level associated to a particular gamble, I can ask you, what is the amount of money that gives to you the same utility level of the result of the gamble? For example, if the result of the gamble can be $25, okay, as before, there is the possibility that for us, $21 is the certainty equivalent. So the amount of money that I will prefer for true instead of the result of the gamble. There is an utility level that is associated to the result of the gamble that corresponds to a particular value that gives to me the same utility level. Okay? So I will